Hello everyone, welcome back to my channel, Prince Automation Destination. This is Prince. I hope you are doing well. So today we are going to continue our discussion on how to identify flaky test cases in the test automation suite. As part of previous discussion, we discussed about how we can identify flaky test cases in Cucumber-based framework along with TestNG. You can check out the same in IAnnotatonTransformer in case you want to check out the same. And today, as part of today's discussion, we are going to discuss about how we can identify flaky test cases in TestNG framework. So what are flaky test cases? Test cases which when executed produces inconsistent results. What does it mean? For example, we are executing it today, so it may pass, tomorrow it may fail, and again it may start passing, right? Meaning the result is inconsistent and we cannot get the confidence that the test script is properly implemented, and it may lose the customer confidence as well. So as an immediate action, we should work upon it. We need to identify this particular flaky test. We need to identify the root cause of it, and we need to provide the fix so that we should not get the inconsistent result. What are the common causes of flaky test cases? Sometimes these are timing issues, like for example, bits are not properly implemented, there is not proper synchronization between the test steps, and there could be application response related issues, meaning the application is slow. Also, there could be network dependencies because the application that we are testing is having external APIs and have database connections or have integration with third-party services. So they may be unreliable or slow. So because of this also, we get the flaky results. Also sometimes because of test data, we may not be properly cleaning up the test data, and as a result, when we are executing the first test case, that test data is not getting utilized properly. So that can also cause the problem, right? Because of the conflict, right? Now, what is the detection statistic? Because this is the first step to fix the flaky test case, that we need to identify it. So the main thing is we need to identify the pattern, right? Because as it is passing sometimes and failing sometimes. So first of all, we need to reach to the condition when it is failing. For that purpose, we will have to systematically run it, meaning we'll have to rerun the same test case again and again, irrespective of failure, right? So that we can reach to the condition where it is failing. And then we need to analyze the results for pass as well as fail. And for the fail conditions, we need to document the pattern, right? And we need to identify the environment, which environment it is failing against, what is the timing, right? And various other factors we can document, right? Now, how we can do it in case of TestNG, right? So meaning because we want to rerun the same test case again, right? So how we can do it? So in TestNG, there is a concept of invocation count. So if we provide invocation count at the rate test annotation or at the test method, so it will rerun the same test case those many times as many invocation count is provided. But this is not the optimized solution, because in real time there would be many test cases, right? And each test case will be annotated with at the rate test annotation. So we cannot go inside each at the rate test annotation and we cannot provide invocation, because this will reduce the readability as well. We cannot do it, right? So what we can do? We can go with annotation transformer, right? Annotation transformer provide a transform method which we can override, and with the help of this particular transform method, we can change the parameter of test annotation, right? So what we are going to do is we are going to use annotation dot set invocation count, and inside this, as many times we want to execute the test case, we can provide that particular count, and this particular parameter we can read from the properties file, right? So this is how we can change the parameter, right? And during execution, we need to configure this particular listener while execution, right? Now, what are the best practices to identify the flaky test cases? First of all, we should run it against different environments. Our test case may be running fine in QA environment, but may be failing at U8. We should execute against different time interval. It may be passing during the daytime, whereas when there is low load, or it may be failing during night when there could be high load, right? And we should test it against different data sets. So for some data set, it may be passing, with some data set, it may not be passing, right? Then corresponding to the execution, we should monitor the logs, we should identify the results. Also, we should look for the screenshot as well, whether there is a screenshot, like what is the failure screenshot and what is the reason, what that we can identify from the UI frame, right? UI screenshot element, right? Then once we have identified these flaky test cases, we need to act upon them. So what we can do is, if environment is flaky, meaning if environment is slow, what we can do is, or environment is, for example, unstable, we can use retry mechanism, though it is not recommended. But if environment is not stable, the first thing is we should get it stable. If they are not stabilizing it, right, but we want to validate the functionality, so we can implement retry mechanism of TestNG. So you can check out the same in IAnnotatonTransformer. I have already covered this video. Once we have implemented this, right, so the first step is, as we discussed, that we need to identify the flaky test cases, then we need to fix it. So one way is retry mechanism, another way is introducing weights, third one is fine-tuning the test environment, right, and changing or using the proper test data, right. So these are the different things that we can introduce to reduce the flakiness, right. So as a result, it will build the confidence in the test automation suite, and we can say that this would be able to find out the bugs, right. Now let us jump onto the practical demonstration. So I'm going to a TestNG framework. So this is the TestNG framework, which is Maven based. Let me go to pom.xml. Here I have a Selenium dependency, which is having version 4.19. Then I'm having TestNG, and corresponding to this Maven project, I have src main Java and src test section. In src main Java, I have created one driver manager where I'm having create driver, right, which is following the singleton design pattern, right. In case you want to understand what is singleton, you can check out my video in IAnnotatonTransformer. Then I have written one set driver method here, corresponding to the browser that will be passing. We are simply like initializing the driver, right, Chrome and Firefox depending on the need, right, and then we are quitting the driver as well, right. So this is how I have implemented driver manager. Okay, coming to src test Java. So I have created 4 pages because the application that I'm going to consider is source demo. Let me show you. So this is the application which has login page and it has credentials already provided. We are going to log in into it. We are going to add an item into the cart. We are going to check out the item, right? So this is what is the test case that we are going to talk about. So we have a login page where we have defined like username, password, and login button locators, right? And created a load-in application method as well. Then we have a products page where we have defined the different elements that we're going to use, right, for adding an item into the cart. So we are adding an item into the cart. We are navigating to the cart, right? Then we have a cart page where we have cart related functionality. Then we have a checkout page where we're going to enter the details of the billing. And at last, we are going to check it out, right? Now this is pages. Then we have a test section where I have created one class, source demo checkout test, right? Inside this, what I've done is before method. So this particular before method will execute before every test method, right? Though we have only one test case, right? So let me minimize this. So this is what this is doing. First of all, it is loading the property by which we can read the property of browser. Then we are calling the set driver using the singleton so that we can initialize the driver, right? Then we are getting the same instance, right? Then we are reading the URL from the properties file. So if I show you under src test resources, I have created configuration.properties as well, where I have defined 2 parameters, browser and URL, right? Same we are using here. Then we are launching the application. We are then calling the page objects, right? So that we can interact with the pages. So we need the object of login page, product page, cart page, because we are going through the entire journey. So now let me come to the test case. So login page dot login to the application where I'm passing the username and password. Then I'm verifying whether the page is loaded or not. Then we are adding an item into the cart. We are navigating to the cart, and then we are verifying these conditions. Then we are proceeding with the checkout. So if I go here, so here we are proceeding with the checkout, right? Then we are entering the shipping details where, for example, I'm entering first name, last name, postal code, right? And so on. Okay. And at last, we are finishing the checkout. And in the after method, which is going to execute after every test method, so it will quit the driver, right? So first of all, let us execute this particular test case. So how we can execute test cases in TestNG? One way is we can click here and we can run it. Another way is using TestNG XML. And inside TestNG XML, we can create test block. And inside test block, we can define the classes. So this is the test class, right? that we are pointing, which is under test package, and this is the class. So if I click here, I will also navigate here, right? Now let me run it, right, from this particular view. Okay. So this is the positive flow where it will launch the application, enter the credentials, add an item into the cart, navigate to cart, and enter the details and going to complete the checkout. Now suppose this particular test case is flaky, right? So to identify this particular test case is flaky, one way is we have to rerun it multiple times. How we can do it? One way is we can use invocation count here, right? So if I provide invocation count equal to 2, it will execute the same test case multiple times. Let me do it. So it will execute this particular test case 2 times. So it completed once. Now it is going to re-execute the same test case again, right? So invocation count is used to execute the same test case again and again, right? But this is not the optimized solution in the real application automation, because right now I have only one test case. So that's why I'm able to do it, right? So in real application, you'll have 100 of test cases. So you cannot go inside each test case and we cannot configure this, right? So what we can do is we can go by the transformer approach. So what I'm going to do, I'm going to create a package and let us give it name listeners. And inside this, I'm going to create a class annotation transform, or let us call it test annotation transformer, right? Because we can transform any annotation of TestNG, right? Now here I'm going to implement IAnnotation transform of TestNG, right? And then we are going to override one of the method of IAnnotation transformer. Let us click on right click, generate, click on override methods, and here you will find this particular transform method where it is giving first parameter as iTest annotation because we want to modify test annotation, right? So here what we are going to do is, let me remove this particular line, right? And let us provide int retry count equal to 2, right? And then annotation dot set invocation down, and here provide retry count, right? So now if I go here, right? So if I run this particular test phase, it will still run once. So let me run it. It will still run once. Why? I'll tell you. First of all, let us observe this and then we will discuss about it. So you see, it ran only once. So why did run once? Because we have implemented this particular, but we are not utilizing it. For that purpose, what we would be doing is, we'll be going to this particular configuration, right? Or what we can do is, we can do it here itself. For example, let me do it here. We need to click here, modify run configuration. And here we need to add listener, right? And we need to add this particular listener, right? If I going to apply. So now this listener will listen to the request and will execute this particular test phase, right? So let me rerun this particular test case, and this time it will rerun it 2 times, meaning it will run the test case 2 times. So it executed once. Now it is executing it again. So you see, it executed 2 times, right? So this is one way, right? But we discussed earlier that we can run the test case of TestNG using TestNG XML as well. So what I'm going to do, first of all, I'm going to edit this particular configuration. Let us modify run configuration and let us remove this particular listener from here, right? And let us click on apply and OK, right? Now I'm going to TestNG XML, right? And this particular TestNG XML is also pointing to this particular source demo checkout, right? But what we need to do, we need to add listeners, right? So we need to add a listener. And which listener we need to add? We need to provide the location listeners dot test annotation transformer. Now if I run this particular test case from TestNG XML, this time also it will run the test case 2 times because we have configured 2 as an invocation count. So it executed once, now it is executing the second time. So this is how we can rerun the same test case multiple times to identify the pattern of failure. Because if we will execute the same test case multiple times, chances of detection of its failures are high. And this is how we'll be able to reach to the root cause of why this test case is flaky. And as a result, we will be able to provide the fix for it and we can gain the confidence into the test automation suite. So this is what I wanted to cover, guys, as part of current discussion. Thank you for watching. I would request you to please like, share and subscribe. Thank you once again.